So this is my ideal gas law simulator, or gas sim for short. If you're watching this video on YouTube, then you can get more information from the video description and maybe get a link to download the app. But if you're otherwise, I assume you're watching it from my blog, which means all the information you need is already on this page. Now the app simulates the motion of gas molecules in a container, obeying the ideal gas law. The reason I created the app, it was my final year project in the university. I'm in the Department of Physics. You can see it at the top here. But I want the app to be useful to non-physics students, so it visually demonstrates. You'll see it once we click on the run simulation button, but before then, this is the home screen, and let me just walk you through this home screen. Then when we start running the simulation, you'll see why I think it should be useful even to laymen. So first of all, the top row shows the various variables that are involved in the ideal gas law: temperature in Kelvin, pressure in Pascal, volume in meters cubed, and molar mass in grams per mole. But I created another row down here to show the same variables in values that a layman is more likely to be comfortable with. Temperature in degrees centigrade, for example, instead of in Kelvin, or volume in liters instead of in meters cubed. So from this screen, we can adjust the temperature. You see, when we change the temperature, the value of the pressure changes. We can increase the volume. We can increase the number of moles or amount of substance. The difference between the number of moles and the volume is that volume represents the size of the container, while amount of moles represents how much gas is in the container. So think of it as the size of a bottle versus how much water is in the bottle, for example. So yeah, okay, I think, yeah, one more thing I can show. I can keep one variable constant, for example keeping the temperature constant, so that when I change the value of the pressure, it doesn't affect the value of the temperature, and so on and so forth. Or I can click down here to keep no parameter constant. It all works. Let me run the simulation and maybe it'll get more exciting for you guys. Okay, so you see here, this is the container at this volume, and it contains 10 moles of gas. 10 moles of gas means 601327828, well, this really long number up here, this number of molecules of gas. Basically 10 moles of gas means we have this number of molecules of gas in the container. But instead of representing it with such a large value, I'm representing it by just 11 balls so that your eyes can follow it. The number of balls is actually just the number of moles plus 1. Notice it's 10 moles represented by 11 balls. So this is the way the molecules would move in their container when they are obeying the ideal gas law. So up here I'm showing the value of all the variables, and to see how it changes, let's assume it starts with 32 grams per mole as so the molar mass is 32 grams. That's the molar mass of oxygen, by the way. If I were to adjust it, let's just say I click this ball and drag it down, meaning I'm making it heavier. Now we're at 70 grams. Notice the speed changes when I adjust the molar mass. The heavier I make it, the lower the speed. Right now the average speed is 218 meters per second. If I make it any heavier, you see the average speed drops to 176 meters per second. So yeah, that's the whole point of this app, just to simulate how the molecules would react to different changes in the variables. Okay, let me give you another example. I'm going to press the P key on my keyboard to keep pressure constant. And now that the pressure is constant, normally we could adjust the value of the pressure by clicking and dragging on this barometer, but since I've kept pressure constant and we can't adjust it, if I were to adjust the value of the temperature right now, look, it increased the volume of the container. See, the volume has gone up if you look right here. What does this mean? Well, basically, let me keep non-constant by pressing X. Okay, no parameter is being kept constant. Now if I were to adjust the value of the temperature, for example, I'm going to reduce the temperature. Look, I'm reducing it. Watch the value of the pressure right here above the barometer. As I'm reducing the value of the temperature, the value of the pressure is reducing too. That's how it works normally. But at the other time, I kept the value of the pressure constant, meaning that the temperature increase couldn't increase the pressure. If the pressure was going to stay constant when the temperature was increasing, then something else had to change. That was the volume. The volume increased. That is basically how the ideal gas law works. It's really a set of complicated formula. Science students are taught these things. They understand it. Chemistry, physics students, mechanical engineering, well, engineering students generally. But a layman should be able to toy around with this app, just randomly change variables and see what changes on screen visually, so he understands it easier. Instead, he doesn't even need to know the formulas behind it. Let's see, if I drop the temperature all the way to 0, see the molecules basically stop moving. They've all frozen in place at 0 Kelvin. But in real life, in real life we never get to 0 Kelvin. So what else can I show you before I stop the video? Yeah, let me show you one more thing. At the bottom right of this app, right here, or if you were to press the F1 key, you would open this screen that shows you the list of all the keyboard shortcuts I've built in. So like press T to keep temperature constant, or P to keep pressure constant and whatnot, M to increase the value of the molar mass, or N to reduce it. Everything is here basically, so you know what exactly you can do from here and what you can't do. Oh, and if you see right here, there's camera controls, so you can also adjust the camera on the fly while the app is running, and you can press enter to print all your results to a text file. Let me return and just show you that. I'm going to press enter on my keyboard right now, and if you're watching, it's printing all the current values of all the variables into Notepad automatically, and it will ask you to save it. It already exists. You want to replace it? Let me just say yes. So we've saved that. Yeah, and if you're curious about the keyboard, the camera controls, you can use the arrow keys to adjust the camera. You can even go into the container if you want to and get a better look. And then if you want to look around and in turn, you press C to go into camera mode, and now when you move your mouse, it moves the camera. You can look around and everything. And if I press C again, switches camera mode off. Even when camera mode is off, you can still use the arrow keys to shift the camera to the side or forward and backward. And if you want to reset the camera to its original position, just press the R key. So that's just a short demonstration on the ideal gas law simulator. You can download the manual or the application. The links should be on my blog or in the video description on YouTube. And well, give me some feedback. Tell me how you find it, and if you like it, or what improvements you think I can add. And I'm actually very curious to know whether anyone who isn't a science student, who was never taught the ideal gas law, would I'm actually very curious to know whether anyone like that toyed with this app for maybe 10-20 minutes and thinks he actually understands the ideal gas law. I put a basic summary or introduction to the ideal gas law in the manual of the app, but even without reading the manual, I'm hoping someone can just toy around with this and actually have a fair idea of what the ideal gas law really means. The app is still buggy, by the way. Sometimes it will crash. If it does, just start it again. It's not perfect yet. I'll try to push out some updates, so you can check back on my blog for updates to the app. Hopefully the feature I'm including in the app that will make it automatically check for updates will work. I'm not sure it will work. I've never actually done that before. I'm still coming up in this software making business. Thank you very much for watching the video.